Alright, today we are working on section 4.5, which is all about determinants. So this is a new aspect of matrices that we haven't talked about yet. So we are going to be talking about some determinants and some ways of finding those determinants of 2x2 and 3x3 matrices. So let's go ahead and jump right in. Determinants. Every square matrix has a number associated with it called a determinant. Those determinants, we're going to talk about how you find those here in a second. 2x2 matrices have what we call a second order determinant. The second order determinant is just the difference of products of the two diagonals. So let's take a look at how we find those. If you have a 2x2 matrix, we indicate the determinant by using almost what looks like absolute value signs. So with the absolute value signs around this matrix, that's no longer the matrix, is the determinant of the matrix. And to do this, we cross-multiply almost. So we have A times D goes first, and then we have B times C, and we subtract those two. So it's always A times D minus B times C. Just to give you kind of an example of how this works, we have this matrix 3, negative 1, 2, and 5. We cross-multiplied, so I have the 3 times 5 is here. And then we have negative 1 times 2 here with the subtraction in the middle. So 3 times 5 gives us the 15. Negative 2 minus that is going to be plus. So the determinant here is going to be 17. And that is what we call the second order determinant of that 2x2 matrix. So let's go ahead and look at finding the determinants of these matrices. All 2x2s. So they just give us the matrix, they don't give it to us in determinant notation. So for us to find this, it's just going to say find the value. You do not have to rewrite it with the absolute value signs, you can just take it for what it is. So again, we're going to have negative 2 times 8 minus, we're going to have 5 times 6. So we get negative 16 minus 30 is a negative 46. And that is the determinant of this 2x2 matrix. Let's go ahead and jump into the next one, part B here. We're going to have negative 4 times negative 2 minus 6 times negative 3. So we have negative 8 plus 18, because we have negative 18 with the subtraction, the double negative gives us a positive, so we end up with a positive 10. And for part C, we're going to have 7 times 2, 7 times 2 minus 4 times negative 3, so we get 14 plus 12 gives us a positive 26. And that is the process for finding the determinant of a 2x2 or a second order determinant. The other determinant we're going to talk about today is the third order determinant, and this is of a 3x3 matrix. We will not go any higher than third order this year. We talk about some of those higher order determinants in pre-calculus next year if you take pre-calculus, but for this year this is as high as we will go. So third order determinants, again, are just determinants of 3x3 matrices. The first method we're going to talk about is what we call expansion by minors. So we don't do multiplication like we did for the last one. We're going to do what we call an expansion of minors. And the minor of a matrix is the determinant formed when the row and column containing that element are deleted. And the best way, I think, to show that is just by actually doing an example of this. So this is what you want to copy down, is this expansion by minors here. So I have this third order matrix with this 3x3 matrix. What I did was, we take the first element. So I focused on, because you're only going to do one row, so I focused on just row number 1. So I started with the first element, and I took it out and it now becomes my scalar. Then I essentially eliminated the row and column that contains that, and I was left with EFHI. And I pulled that out, and I'm now going to find the 2 by 2 determinant of that. Then we switched to subtraction, and now I focused on B. So once I eliminated the row and column that contains B, I was left with D, F, G, and I. And that came over here, and I now create the 2 by 2 determinant of that matrix. And then again, we move on to our C value. And when I eliminate that row and that column, we're now going to be left with D, E, G, and H. And that's the new 2 by 2 that we're going to find for the determinant. So that's how expansion by minors works. It's essentially just finding a whole lot of 2 by 2 determinants. And that gives us the determinant of the 3 by 3. So let's look at two examples of this. The first one, again, notation is the same with these absolute value symbols. So I'm going to again, you can choose any row or any column that you want to focus on here. So I'm going to focus on this last one only because it contains a 0. So really that last piece of that is going to all be multiplied by 0 and it goes away. So there's not really a lot of work to do there. So first we start with 6. And I'm now going to have a 2 by 2. I eliminate the column and row that is contained with 6, and I'm left with 7, -3, 5, and -4. Subtract 9. So let me get rid of these lines. And now we're going to eliminate 9's row and column. And I have 2, -3, -1, -4. And then again we go back to addition, but it's with 0 this time. So I'm going to write it out just to show you the process of this, but this whole thing is going to be deleted because we have the whole determinant multiplied by 0. So we have 2, 7, -1, and 5, and this whole thing will become 0. So the determinant over here, we have 6 times the quantity. Again, we cross multiply, going back to what we just did a few minutes ago with 2 by 2's. So I'm going to have 7 times -4 minus -3 times 5. And that's the first one. Minus 9 times 2 times -4 minus -3 times -1. That's the second one. And then again, I could write this all out. I'm not going to. Save myself the work because it's all going to be 0. So down here we have 6 times the quantity, -28 plus 15 minus 9 times the quantity, -8 minus 3. So I have 6 times -28 plus 15 is a -13 minus 9 times -11. That's going to give me 6 times a -13 is going to give us a -78 plus 99. That's going to give us a positive 21 for our determinant. And that is the value of the determinant of that 3 by 3 matrix. So I'll give you a minute so you can kind of follow along there and copy those things down, because I will erase those here in a minute so we have room to do the second one. And don't forget, anytime you need to, you are always welcome to pause the video, go back, rewind the video to review how I did an example, or just to catch up on some things if I'm going faster than you need to. That is kind of the benefit of us doing it this way, is that you have unlimited access to all of these things. So let's go ahead and do part B. Now there are no zeros in here, so there's really no rows or columns that are more convenient than anything else. So I'm just going to go ahead and we're going to focus on that first one. So I'm going to go ahead with a -2 times the determinant. I eliminate this row and this column, so we're left with -3, 8, -6, -5. Again, it's always subtraction, So then we have 3. We get rid of the column and the row here. So we have 5, 8, 4, negative 5. Again, it should be addition, but because it's negative, we're going to have subtraction again. So we get rid of this row and this column, and we have 5, negative 3, 4, negative 6. So we're going to go ahead and do these 2 by 2 determinants here. So when we look at these, we're going to have the negative 2 out front. We're going to have negative 3 times negative 5, which is 15. And then 8 times negative 6. So a subtraction of a negative 48 here. Then we have negative 3. We'll have 5 times negative 5 is a negative 25. 4 times 8, minus 32. Minus 1 times 5 times negative 6 is a negative 30. Minus negative 3 times 4 is a negative 12. So let's go ahead and simplify some things here. So we have negative 2. We'll have 15 plus 48. Negative 3. Negative 25 minus 32 is going to give us a negative 57. And we have minus 1 times negative 3 plus negative 30 plus 12. So let's continue reducing these. We have negative 2 times 63 minus 3 times a negative 57 minus 1 times a negative 18. So we have negative 126 plus 171 plus 18. We get a final answer of 63. So I'll give you guys a minute to kind of follow along with that one. Take some time to write that down. Again, pausing it if you need to before I move on and erase it. Alright, the other way, which in my opinion is a whole lot easier, is what we call the diagonal method. And this one really just comes down to some rewriting it and then some multiplication here. So what we do is we have our determinant of the 3 by 3, and I rewrite the first 2 columns here. So I rewrote the ADG, ADG, BEH, and then I had the BEH. And what we're going to do is we go through, and I'm going to first start by multiplying down. So I multiply the AEI, then I multiply BFG, and then I multiply CDH. And that's what all of these things are. And I add those up. Then I go through, and I'm going to multiply going up. So I'm going to start at the bottom and move upwards. So then we have GEC, HFA, IDB. And we subtract each of those numbers. So even if it's not a negative, we subtract it. If it is a negative, it'll end up becoming a positive number. So that's how you do the diagonal method, and then you just do all the addition and subtraction, and we should get the same answer as if we were to do expansion by minors. So let's go ahead and take a look at this example here with evaluating this by diagonals. So again, I'm going to rewrite this so I can give myself some space to work. Now I rewrite the first 2 columns. We have negative 1, 4, and 0, 3, negative 2, and negative 5. Okay, so now that I've rewritten these, we're going to start by multiplying downwards. So we have negative 1 times negative 2 is 2, times 2 is 4. So that stays positive. 3 times negative 1 is negative 3 times 0 is 0, so we just add in a 0. And then negative 3 times 4 is negative 12, times negative 5 is a positive 60. So those ones we add, and those are all positive. Negative 0 times these numbers stays 0. Negative 5 times negative 1 is a positive 5, times negative 1 is a negative. We have a subtraction of that. And then we have 2 times 4 is 8, times 3 is 24, and we subtract that number. So we get 4 plus 60 is 64, plus 5 is 69, minus 24 is going to give us a 45. And that's the determinant. So again, in my opinion, this goes a whole lot faster than doing it the expansion by minors. You just have to remember correctly which way you are adding and which way you subtract. And that concludes session 4.5. So here is your homework. Again, this is the homework that you'll be doing in class tomorrow, which will be page 198, 9 through 25, the odds, and then we're adding in that 26 and 27 there at the end.